All right, this is a comprehensive review of the Geometry Unit 4 for the pullout class. I'm going to run through all the sections of the review and make sure we cover what you need to know. A lot of the information here is going to be in the notes from class, so you need to be referring to those. All of that's already been given to you, so here we go. Looking at part A here. This is going to be based on some vocabulary about polygons. The first thing is concave versus convex. So concave and convex refers to the sort of direction of the vertices. The vertices are all the corners of the polygon. So all of the corners, based on which way they point, is going to be determined to be concave or convex. The big idea here is that if there's a spot like there where the polygon caves in, so to speak, there's a point going inward, that's going to be concave. So the only concave polygon of these three is the first one here. The other two are going to be considered convex because all of their vertices point outward. So that's pretty much all you need to know on that one. So you need to know that difference, and that's what you need to be looking for when you sit down to the unit. Or sorry, to the test. Okay, next, regular or irregular. So regular and irregular is very straightforward. It's only regular if all of the sides are the same measure and all of the angles are the same measure. So you're looking at something like what you see here in the middle. Because all of these angles are marked as the same and all of these sides are marked as the same, this is going to be a regular polygon. The other two are not. They are irregular because they do not have all the same sides on all the same angles. And that's pretty much all you're looking for. That's what you need to know. All right. And then the third thing on here, again, is coming from your notes. You need to memorize the names for the polygons based on the number of sides. You can run through that, or you can just Google it, honestly, if you don't know. But this one is 1, 2, 3, 4, 5, 6 sides. So that is a hexagon. That's the name for a six-sided polygon. This is 1, 2, 3, 4, 5, 6, also a hexagon. So notice it doesn't have to be regular for it to be one of these names. It just is about the number of sides. This is 1, 2, 3, 4, 5. So this is a pentagon. All right, so that's pretty much it for part A. Again, you need to refer to your notes and the vocabulary. You need to know all of this by heart. You will not get notes on this part for the test. Looking at the next section, this is going to be some formulas that we covered in class. So the formulas, I'll write them down and then I'll work them out. So the formulas are all going to use this value n. And n is the number of sides in whatever figure you're looking at. So this 5-sided polygon is going to have an n value of 5, and that is the number I'm going to plug into all of my formulas. So the formulas in order are as follows. We have n minus 2 times 180. That is the value of the sum of the interior angles. And so for this one, I'll do it in a different color when I do my work. I'm going to put 5 where the n was, and that's how I'm going to work out my answer. So 5 minus 2 is 3. So I'm going to do 3 times 180, and I get 540 as my measure of my sum of my interior angles. So notice I put 5n for the n value here, and then I'm just working out the answer. And I need to put a box around my answer to show that I know that is the answer for A. Then I move on to part B. Part B, the formula looks like this. Before we do it, I'll note something that you should recognize. What you should recognize is that the first part of this formula, the top part of the formula, is exactly the same as the formula that we did up here. I'm going to erase this because it looks a little weird. Fix that. N minus 2 times 180 divided by n. I wrote that wrong. Sorry about that. This is the formula there. So that means that I know that the answer I got in part A is actually going to be the answer to the top part of this fraction. So in a sense, I'm taking this 540 and I'm bringing it down and using it in part B. And then I'm dividing by n. N is still 5. I'm using the same number I used here. I'm always putting 5 in anywhere there's an n. And when I do that in my calculator, I get 108 degrees. And that is the answer for part B. Looking at part C, the formula for part C is simply to do 180 minus the measure of each interior angle, which is what I found in part B. So again, I'm taking the answer from part B, and I'm doing 180 minus that answer, 108, and I end up with an answer of 72. So you'll notice how I'm taking the answer from A and putting it into B. I'm taking the answer from B, I'm putting it into C, and that's how I'm getting those answers. So that is how you complete those first three. Now, starting in part D, it's a little bit different. You have a different formula. It's n squared minus 3n divided by 2. And so again, everywhere there's an n, I'm going to put 5. I would not recommend typing this all into the calculator at once because you will likely make mistakes. I would recommend working it out piece by piece. But that is what you get when you plug 5 into n in both places, here and here. I've replaced those with 5 because that is my n value. And then I work it out. 5 squared is 25. 3 times 15 is, 3 times 5 is 15. And I just continue working it out. 25 minus 15 is 10. 10 divided by 2 is 5. And so there are 5 diagonals in my 5-sided polygon. There are other examples worked out from our notes, and there's a video that I've shared previously about how to do these, but that's one complete worked out example. You do not need to memorize what is in purple on the screen. What is in purple, or inside this blue box, I guess, is part of what you get to bring to the test as notes. So just be aware of that, but that is what you need to know for part B. All right. The next section. In the next section, we are looking at the names of the different types of triangles. You have notes for this. This is the one where we cut out triangles out of colored paper. So I'm going to run through these answers and just remind you of what each thing is referring to. Looking at the first one, because all 3 sides are the same right there, I am going to know that that is an equilateral triangle. Oops, sorry about that. An equilateral triangle. So this is equilateral because all 3 sides are the same length. And actually, while I'm at it, number 7 is also equilateral. It is equilateral because, again, all of the sides have the same length. We're actually skipping number 5, so let me actually mark that out before we move on. So that's the first thing. Every single triangle is going to have a name that talks about its sides and a name that talks about its angles. So let's look at this one in reference to its angles. I'll do that in a different color so it's clear what we're talking about. So if I look at the angle part, I can see that an equilateral triangle, you should know this from the notes, is also an acute triangle. And I can actually go and write that down here as well. An acute triangle is a triangle in which all 3 of its angles are acute, which means they're less than 90 degrees. It's pretty clear, even just looking at this, that these angles are all less than 90 degrees because you know a 90-degree angle is going to be a straight right angle. It's going to be like a corner of your paper. So just be aware of that. All right, so looking at the next problem, number 2, this is an isosceles triangle. Isosceles triangles have just 2 sides that are the same length. This is an isosceles triangle because there are 2 sides that are the same, not all 3. So that means that number 6 is also an isosceles triangle because of the way it's marked. And number 9 is an isosceles triangle. Those are all isosceles because they have two sides that are the same length and they're marked that way. Now, if I look at the measure of the angles, I can see this has a right angle right here. That automatically means that this is a right triangle. Do not hesitate on that. If you see a right angle, it is automatically a right triangle. In fact, looking down at number 4, I can go ahead and write that as well. That is a right triangle. Pretty straightforward. Now, let's compare that to the other two that we just did that were isosceles. Number 6, this angle here is an obtuse angle because it's bigger than 90. You can see it's open more than a right angle would be. And so that automatically makes it an obtuse triangle. All it has to have is one right angle to be a right triangle or one obtuse angle to be an obtuse triangle. And then down here at the bottom, this is going to be an acute triangle because, again, all 3 of those angles are acute. So you'll notice an isosceles triangle can be right, it can be obtuse, it can be acute. But you need to put both names to get these questions right. Now, looking at our next problem. Because none of the sides are marked, we automatically know that this is a scalene triangle, which is the triangle type that is no congruent sides. Also, number 4 is scalene, again, because none of the sides are the same length. They're all 3 different sides. And the reason we know that is because there's no markings telling us anything other than that. And then that also is true of number 8. I'm going to have to squeeze in my, there we go. This is going to be scalene as well. Again, no markings is indicative of the fact that there is no 2 that are the same length. And then this is going to be, number 3 is going to be obtuse, again, because we can see that there is an obtuse angle. Should be easy to recognize. It's right here. It's bigger than 90 degrees. And actually, same thing with number 8. This is also an obtuse triangle because that angle is bigger than 90 degrees. Simply put, you need to study these words. You need to know them. You really need to know how to spell them. It's not that many names to know. It's actually 6 different names that you need to know. And you are expected to know those on the test. So just make sure you have those all down and ready. All right, let's look at the next section. The next section is all about finding the measures of the triangles. All of this is basically going to come from the idea that the angles of a triangle have to add up to 180. So if I look at this, these 3 angles have to add up to 180. So simply put, the way to find the answer is to just do 180 minus the ones that you know. You can do this in the calculator, but I'll just go ahead and say what the answers are while we're on here. This is going to be 89. So that is telling me that that x is 89 degrees because 180 minus 51 minus 40 is going to give me the leftover angle. Same thing with number 2. I'm just taking 180. I'm subtracting 45. I'm subtracting 71. And you get, we got to look over on my 64. When you subtract those, and that's going to be the measure of angle X. There. Again, very straightforward for this part. Now, if I go to the next part of this section on the following page, let's jump over here, adding a few extra elements. These are not new. These are things we learned in the previous units. The first thing is that this is a linear pair. And we know that a linear pair adds up to 180. So that's telling me that this angle 128 here in purple and this angle here in blue are adding up to 180. So I can do 180 minus 128, and that gives me 52, and that's what goes here. And then I can use, I'll use a different color, I can use these 2 angles together to find the value for x by doing 180 minus 96 minus 52. Minus 52, there we go. And you get 32. degrees for the x. Notice you have to just do that extra step. Similarly, in the next problem, this right here is a vertical pair. Vertical angles are congruent. So we know that if this is 48, then this is also 48. And then all I have to do is do 180 minus once again. So I do 180 minus 48 minus 41. And I get 91 degrees for my missing angle here, 91 degrees. On the bottom here, not much else to say except this is just a right triangle, so we automatically know that this is 90. We don't actually have to have it written, and that just means that I'm going to do again 180 minus 62 minus 90, and I'm going to get 28 degrees from that, and that's going to be the measure of my x over there. Again, I'm moving fast because it's all straightforward. Everything's going to be either 180 minus the two angles to find the missing angle, or do some step first, either linear pair or vertical angles to get towards the answer, and then doing that last step to get the final answer. All right, almost there. Looking at part E right here. All that you need to know here is that you need to be able to write the names of these triangles in a corresponding way. That means that when we say corresponding, that we need to know that like A goes with P because they both have the same kind of mark. And so when I go to name these triangles, the way you're going to write it is you're going to write what's called a congruence statement. And each part is going to be named. So A, B, C is the name of this triangle. A goes with P, like I just said. B goes with Q. You can see how they're marked the same way. So then Q is going to come next. And then C, right here, and R are going to go together. And so R is going to be my third one. And so this is what the answer looks like for problems like this, where you're asked to just write a statement about the pairs of things that are corresponding. But you have to match them up based on the markings. That's very similar to what you're doing in the next section. It's directly related. And on the test, this is the way it's going to look. You're going to have a pair of triangles, and you just have to say which part goes with which. Well, LN is this part right here, so it's going to match up with this, but specifically it has to match up with the number of markings. So A and L go together, so A needs to come first in the name, and C needs to come second, because LN matches a C in terms of the way that those are marked. And then separately, angle B, which is this angle right here, corresponds with angle M because they have the same number of marks. And so that's going to be angle M. So all you're doing there is just matching up the parts based on where they're located in the triangles. All right, lastly, the last section is going to deal with the different triangle congruence theorems. So I'm going to write those down. The triangle congruence theorems that we learned in class, and you have these in notes, and you're allowed to use it on the test, are S, 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 which is when there are three sides that are congruent. There's SAS, which is when there's two sides and the angle in between. There's ASA, when the angles are around the side, when there's a side in between two angles, and then angle, angle, side, when it's two angles and a side not. So all we're doing is we're looking at the pictures and see if they match the patterns of any of these four options. And if they don't, we're going to put no. If they do, we're going to put yes. So looking at the first one, I see that there is a side here that's congruent to a side here. There's a side here that's congruent to a side here, and an angle here that's congruent to an angle here. Now when I look at these two triangles, I can see that this triangle here, side, angle, side, and this triangle here also is in the pattern side, angle, side. So the patterns match. That's the whole idea. You got to look for a pattern in the two triangles and noticing that they are in the same arrangement. And specifically, these are in the side, angle, side arrangement, and that is your answer. Number two, also very straightforward. You have a pair of sides that are congruent here. We have another pair here, and we have another pair here. All three sides have a partner in the other triangle. That one's easy. You don't even have to check the arrangement because those are in the side, side, side congruence arrangement. Okay, now looking at number 3, again, we mark everything that goes together. We have angles here, we have angles here, and we have side and side here. Now, this is where a problem arises, and you need to be really careful. If you look at these two triangles, you can see they both have 2 angles and a side, but they are not in the same arrangement. The first triangle is in the ASA. So we have an angle, we have a side, and we have an angle. And then the second one, we have 2 angles, but the side is not in the same place. It's not between the 2 angles like it is over here. So this second triangle is not in the same arrangement as the first triangle. And if that happens, you're just going to put not congruent because they are not congruent for that reason. All right. Looking at number 4, we have a pair of angles. We have a pair of sides. And then the thing that's hidden that you need to recognize is that this relationship here, this is vertical angles, that also gets marked as a side. And so this is angle, side, side. The problem is that that is not one of our options. The only way that we can have 2 sides and an angle, and I just messed that up. Woo. Back up, Mr. Matthews. All right, let's rewind this. Sorry about that. This is angle, angle. You're probably thinking, well, why did he mark those as sides? This is angle, angle here, not a side. And that does match a pattern. It is angle, angle, side. Now, the reason it's angle, angle, side and not angle, side, angle is because the order of the sides is that the side is not between the angles. It would be here if it was between them. It's separate around the other part of the triangle, and that's why it's angle, angle, side. Looking at number 5, again, more of the same. I'm looking at the different parts that match. I have a pair of angles here and here. I have a pair of angles here and here that match. And then because these share a side down the middle, that S counts for both triangles. And that one's very clearly angle, side, angle, angle, side, angle, because of the arrangement of those parts. Looking at the next one, I've got a pair of angles. I've got another pair of angles here. And then I have a shared part, which is going to count as a side for both. And the side is not between the angles. So then that's going to be angle, angle, side. Again, it's because the side would need to be here for it to be the angle, side, angle, but the side is separate from the angles. It's on the other part. Number 7. Again, we have a pair of sides. We have another pair of sides. And then we have this vertical angle relationship. And so, again, very clearly, even the way it's written, side, angle, side. Okay, looking at number 8. We've got a pair of sides. We've got a pair of sides. And we got an angle there and an angle there. And those are also in the angle, side, angle relationship. We've got the 2 sides and the angle in between them. We've got the 2 sides here and the angle in between them. That is going to be side. Sorry about that. I don't know what happened. Let's get back to it. That one's going to be side, angle, side. Sorry about that. And then looking at this last one, we've got a pair of sides. We've got a pair of sides. And we've got a pair of sides in between. And so all we have is sides. When all we have is sides, that's easy. It's just side, side, side. There are a few more on the next page. I'll leave those for you to do, and you can always come look at the answer key when you're done working. But that's a summary of all the material from Unit 4. Hopefully this will help. Study. Please make sure you study the things you need to know and that you know how to use the tools that you're given. Remember that you do not need to memorize these theorems. they'll be given to you on the test in the form of your notes.